Creating a viable future for UK steel industry. I just concatenated it to say saving British steel. There is a metaphor in this because the name of the company that is now called as Tata Steel UK was at one point of time called British Steel. This is the scheme of the presentation, and what I'm going to present today is what I learned over since 2003, 2004 that I came into contact with Goldratt for the first time, till now, whatever I have learned. I tried to use it because consequences were disastrous otherwise. And that is what is the story I'm going to tell. The board of Tata Steel Limited said, enough is enough. What do you do then? We started a new journey called Delivering Our Future. Within a year, from roughly minus 200 pounds of loss, we swung back to about 100 million pounds. 300 million pounds swing in a year. But all of it was not our work. We realized that during that time, the market had moved. There were tailwinds in the market. So how do you create a burning platform when people think that, oh, we were in crisis, now we are okay, we are in the green? This is when we created this chart to tell the people how much we are not in green. So we took out the tailwind effect and we were still below zero on the all-weather condition. So we defined it as an all-weather result. And we therefore said, if the conditions of 2015-16 were to arrive again, are we ready for that? And if we are not, how much would it be necessary to be ready? And we defined that number over here. Once you define that number, then your idea bucket has to be big enough that 1/3 of it you take as a buffer. And then you say, how much is the idea bucket that you need? And we realized, coincidentally, it was as if from 1 million pound loss a day, we needed 366 million pounds, which is for a leap year, £1 million a day of improvement. Look at this journey for the retained business. How the financial crisis took us down, a bit of a breather up, and since then we were down till this point, and then we have been for a couple of years here. We can't be satisfied, meaning we need to focus on throughput, meaning somebody needs to help. Alan, why don't you help?
Firstly, it's been an incredible privilege to be part of this incredibly exciting but challenging journey. I met with Bimlendra. We've been friends for many years, and whenever we had complexities, we used to exchange calls. And he called me in around the end of 2016, and he took me through this whole journey. And he said to me, I have a major challenge. We need to find this next big step change. We've tried to kill all the complexity that there is, and at the same time, we've got a major issue with some of the changes that need to be made. It's very counterintuitive, and we're going to get resistance. And that's obvious because you can't expect people to support changes for which they have no intuition to judge what the likely impact will be. I think when it comes to complexity, ignorance is bliss. Absolute bliss. When you think about the complexity of these systems and how sensitive they are to starting conditions, it's no wonder that people are terrified to make changes. So the first thing that we agreed upon is we needed to find out what are the complexities that could be avoided. Where could the system be further decoupled? And then provide some kind of decision support to the management team to allow them to better predict the impact of these changes, because it was an ambitious plan, and Bimlendra and his team needed to be absolutely confident that whatever they were proposing would have the impact. We ended up building 4 simulation models as part of this journey. And I think most of you have seen this curve of what happens when you get close to maximum utilization of any resource. You have this exponential growth in Q, in the lead time, and an exponential decay in the reliability. But what also happens is your throughput starts growing, then it plateaus, and then it drops when you go into chaos. And you now have a vicious cycle that's really difficult to escape from. You have overproduction to keep things busy, and as a result, you can't make reliable commitments. It's theoretically impossible, not just practically. So you overcommit. You say we can do 3.5 when actually you can only do 3.2. And you can't get out of the cycle. Because as you undercommit, you feel pressure to start even more things, making the system even more unstable. So what's the solution? We know the solution, but the solution is very counterintuitive. We are asking people, if you look at Little's law, there's a good approximation of what this dynamics is. It says throughput is WIP over lead time. What will happen if I reduce WIP? People are terrified because mathematically, if I reduce WIP, throughput will go down. That is true if I'm in the stable part. But if I'm in the scale zone, By reducing WIP, my lead time will drop disproportionately. I get an asymmetrical benefit in my favor, and as a result, throughput has to go up. But now you're asking people, when they're already overcommitting, to reduce WIP. It's terrifying. And that's the answer that the simulation model could offer, that Bimlendra was asking for help. We found many cases that was counterintuitive. Buying the lowest cost wagons would give you the highest total cost. I think a key one, just as an example, I want to end off with, and then I'll show you quickly what the models look like, and we'll ask Bimlendra to just finish up, is an industry paradigm around running large batches, because every time you make a change, it's going to cost you a ton dish, which is about $5,000. So they were running typically between 6 to 11 heats as the minimum. This is what the financial situation looks like when you have a batch of 6 to 11. And that's what your profitability looks like, and your cost per unit, which is about $407. And we could use a simulation model to show what would happen if we completely ignored it. If we needed only one, to switch over to not selling whatever you've produced, but only producing what you've sold, look what happens to your cost per ton. Actually goes down. And that's completely counterintuitive. This model is going to run just a little bit to show you the kind of complexity of what it takes to create an accurate model of a whole supply chain. We had an Excel spreadsheet that was about 70 sheets long that was reading in data from the plant in order to accurately model. So it's self-configuring the full supply chain based on data that exists in the existing IT systems. From this, we could test any key question. We could see why congestion was happening. We could see why we were losing throughput. We could zoom into specific parts. We had another model for the hot coil finishing. We wanted to see the congestion there. Why was it filling up with coils? And there, the 3D animation is absolutely critical, because you can see what happens when a crane suddenly is delayed because it has to go 3 levels deep to find the coil that it's looking for, and suddenly your cycle times are just so long that it suddenly becomes a bottleneck. You've got congestion, it backs up, and your real bottleneck starts losing throughput. So all of these models were created to provide the management team with decision support to test every single rule that they were considering to change, or the investment that they were making. And we had incredible insights. The tough challenge with these is to think as Bimlendra does from a systems perspective, to even know what questions to ask.
And what I want to tell you was that £1 million a day target, that was onerous at this point in time. 366 million was required. As on date, we have 303 million pounds. And every day in the evening, I get a report how much our idea bucket has improved, which projects are running behind schedule, which projects are running ahead of schedule. And this is a daily report. It's not weekly or anything. It's ambitious goal setting, which reduces the choices and creates greater focus. Failure is not an option here. That is what is our story.